Welcome to third session of chapter 2 polynomials. We have already studied about the factorization of polynomials by splitting the middle term. Now in this session you are going to learn the factorization of cubic polynomials. The splitting the middle term method is not applicable for cubic polynomials. So it is needed to find at least one factor first by trial method and then adjust the given polynomial such that it becomes the product of term in which one of them is the factor that we find out and the other is a quadratic polynomial. Then you can solve the quadratic polynomial by splitting the middle term. In exercise 2.4, question number 5, factorize x cube minus 2x square minus x plus 2. The polynomial is having the variable x and the highest power 3, therefore it is a cubic polynomial. In cubic polynomials, to find the factors, splitting the middle term is not possible. So for that, you have to first find a factor of this. For that, you have to take the constant term, that is plus 2. Find the factors of plus 2. The factors of 2 are plus or minus 1 and plus or minus 2. From this, take any one factor and which factor comes as a 0 of the given polynomial. That means you take a number and find p of that number. If you are getting 0 as answer, it is a factor. So you are taking first plus 1. So find p of 1, that is equal to 1 cube minus 2 multiplied by 1 square minus 1 plus 2. So you have 1 minus 2 minus 1 plus 2, that is equal to 0. Since p of 1 equal to 0, you can write x minus 1 is a factor of p of x. Now you got one of the factor as x minus 1. To find the other factors, one method is you can divide the given polynomial by x minus 1 and you will get a quadratic quotient polynomial and you factorize the quotient polynomial. Otherwise, you can use the factor theorem here. That means from the given polynomial, you have to take x minus 1 as a common factor outside. For that, you have to adjust the terms accordingly. For example, you just check the first two terms, that is x cube minus 2x square. You have to take x minus 1 as a factor. So you are splitting the second term as minus x square minus x square. That means it is minus 2x square. Take the first two terms x cube minus x square. From that, the highest factor you can take outside is x square. So you will have x square multiplied by x, that is x cube minus 1 multiplied by x square, that is minus x square. So you got a term having x minus 1 as a factor. Now moving into the third term, you are already having minus x square and here it is minus x. If minus x square and minus x are coming, if you are taking minus x common, you will get the factor as x plus 1. So to make it x minus 1, you split the term minus x as plus x minus 2x. X minus 2x is minus x only. So from the next two terms, that is minus x square plus x, you take minus x common. So you will have the common factor, that is x minus 1. Minus x multiplied by x minus 1. Minus x multiplied by x is minus x square. Minus x multiplied by 1 is minus 1 is plus x. Now take the last two terms, that is minus 2x and the constant term plus 2. In that you take minus 2 as a common factor, you will have minus 2 multiplied by x minus 1. Now look into the three terms. You are having x minus 1 as a common factor. So you take x minus 1 outside. You will have x minus 1 multiplied by x square minus x minus 2. Now this is a quadratic equation. You can, if possible, you can find the factors by splitting the middle term. So the sum will be minus 1 and the product will be minus 2. So which are the two factors of that? That is minus 2 and plus 1. So you will have x minus 1 multiplied by x square minus 2x plus x minus 2. That is, from the first two terms x is common, so you can write x multiplied by x minus 2 plus, from the last two terms you are having 1 as a common factor, so plus 1 multiplied by x minus 2. Now in both the terms you are having x minus 2 as a common factor. If you are taking the common factor outside, you will have x plus 1. So the factors of cubic polynomial is x minus 1, x minus 2 and x plus 1. That means you are for the cubic polynomial you are getting three factors. It is difficult to understand. Please try to practice it, then it will be easy for you. Now question number 5, in that third one, x cube plus 13x square plus 32x plus 20. It is a cubic polynomial. So to factorize a cubic polynomial, first you have to find one factor by trial method. For that, you take the constant term, that is plus 20, find the factors of it, and in that take one of the factor and check which factor is coming as the 0 of the given polynomial. So it is better always you start with plus 1 or minus 1. Here teacher is going to take p of minus 1. That means replace x by minus 1. You will have minus 1 cube plus 13 multiplied by minus 1 square plus 32 multiplied by minus 1 plus 20. So you will have minus 1 cube, that is minus 1, plus 13 multiplied by minus 1 square, that is plus 1. 13 multiplied by 1 is plus 13, plus 32 multiplied by minus 1, that is minus 32 plus 20. Adding these terms you will get minus 33 plus 33, that is equal to 0. That means p of minus 1 equal to 0. Therefore, x plus 1 is a factor of p of x. So you got one of the factor as x plus 1. You can get the other factors by dividing the given polynomial by x plus 1. You will get a quadratic polynomial and factorize the quadratic polynomial by splitting the middle term. You will get the rest of the factors. Or you can use the factor theorem to to get the factors. Now the given polynomial x cube plus 13x square plus 32x plus 20. In this, from the first two terms you have to take the x plus 1, that as a common factor you have to take outside. So x cube plus 13x square. If you are having only x square here, your factor will be x plus 1. That means you have to split 13x square as x square plus 12x square. So from the first two terms, you can take x square as a common factor. So you will have x square multiplied by x plus 1. Now in 13x square you have taken only 1x square. The remaining 12x square is here. 12x square. Now from 32x, you split 32x in terms of 12x plus 20x. That is total 32x. So from 12x square plus 12x, you can take plus 12x common. Then you will have 12x multiplied by x plus 1 plus 20x plus 20. From that you can take plus 20 as a common factor. 20 multiplied by x plus 1. So here you are having 3 terms with x plus 1 as a common factor. So take the common factor outside, you will have x plus 1 multiplied by x square plus 12x plus 20. Now x square plus 12x plus 20 is a quadratic polynomial. So you can factorize it by splitting the middle term. That is, the sum of, take two numbers such that sum of the two numbers is 12 and the product is 20. So you can take the factors as 10 and 2. So by splitting the middle term you have x square plus 10x plus 2x plus 20. From the first two terms x is common, so x multiplied by x plus 10. From the last two terms 2 is common, 2 multiplied by x plus 10. From the two terms x plus 10 is a common factor, so x plus 10 multiplied by x plus 2. So you got the three factors of the cubic polynomial as x plus 1, x plus 10 and x plus 2. Now moving to algebraic identities. Identities you have already studied in 8th standard. An algebraic identity is an algebraic equation that is true for all values of the variable occurring in it. The first identity is x plus y whole square, that is x square plus 2xy plus y square. Then x minus y whole square, that is x square minus 2xy plus y square, and x square minus y square, that is equal to x plus y multiplied by x minus y. Then x plus a multiplied by x plus b, that is equal to x square plus a plus b multiplied by x plus ab. And the fifth identity is x plus y plus z whole square equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now these are the identities that you are learning the first time, that is x plus y whole cube equal to x cube plus y cube plus 3xy multiplied by x plus y, and x minus y whole cube equal to x cube minus y cube minus 3xy multiplied by x minus y. Then the last identity, that is x cube plus y cube plus z cube minus 3xyz equal to x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus zx. If in this identity, if x plus y plus z equal to 0, then x cube plus y cube plus z cube equal to 3xyz. Now while learning the identities, you have to learn both the LHS and RHS. If you are learning the LHS, expansion of the identity is easy for you, and if you are learning the RHS, for factorizing using identity, you can directly factorize the given polynomial. So it is compulsory to by heart all the identities, then doing sum will be easy for you. Exercise 2.5, question number 1. Use suitable identities to find the following product. In that question number 1, x plus 4 multiplied by x plus 10. Now x plus 4 multiplied by x plus 1, x plus 10, you can use the identity here as x plus a multiplied by x plus b, that is equal to x square plus a plus b multiplied by x plus ab. Here A is 4 and B is 10. Now you can just substitute the values in the identity. You will have x plus 4 multiplied by x plus 10 equal to x square plus 4 plus 10 multiplied by x plus 4 multiplied by 10. That is x square plus 14x plus 40. Now question number 2, that is x plus 8 multiplied by x plus 10. The same identity you can use here. Using identity is x plus a multiplied by x plus b, that is equal to x square plus a plus b multiplied by x plus ab. Here a is 8 and b is minus 10. You replace by a and b as 8 and minus 10. You will have x square plus 8 plus minus 10 multiplied by x plus 8 multiplied by minus 10. You will have x square minus 8 plus minus 10 is minus 2x. 8 multiplied by minus 10 is minus 80. Question number 2. Evaluate the following products without multiplying directly. In that question number 1, 103 multiplied by 107. That is 103 you can write it as 100 plus 3 and 107 you can write it as 100 plus 7. Now look into the number, that is 100 plus 3 and 100 plus 7. Which identity we can use here? That is x plus a multiplied by x plus b equal to x square plus a plus b multiplied by x plus ab. Here x is 100, a is 3 and b is 7. Now you just substitute the values in the identity. You will have 100 square plus 3 plus 7 multiplied by 100 plus 3 multiplied by 7. That is 100 square is 10,000 plus 10 multiplied by 100 plus 7 3s are 21. Adding the terms you will get 10,000 plus 1,000 plus 21. That is 11,021. Moving to third question, that is 104 plus 96. Seeing the numbers, you have to split the numbers in such a way. You have to use the identity. So you are splitting 104 as 100 plus 4, 96 as 100 minus 4. Now this is the identity of the form a plus b multiplied by a minus b, that is equal to a square minus b square. Therefore 104 multiplied by 96, that is equal to 100 plus 4 multiplied by 100 minus 4. Here a is 100, b is 4. That is 100 square minus 4 square. 100 square is 10,000. 4 square is 16. 10,000 minus 16, that is equal to 9,984. Question number 3. Factorize the following using appropriate identities. In that question number 1, 9x square plus 6xy plus y square. Look into the given polynomial. It is having the power highest power 2 and it is having variables x and y and all the terms are plus. Now you have to think about an identity with all the terms plus and it is a power of 2. Now look into the first term, that is 9x square. You can write 9x square as a perfect square, that is 3x whole square, and the last term y square you can write it as y whole square. Since all the terms are plus, you think about the identity a plus b whole square. Is it possible to write in the form a plus b whole square? So it is a square, that is 3x square plus 2ab, that is 2 multiplied by 3x multiplied by y plus b square, that is our y square. So it is of the form 9x square plus 6xy plus y square. So you can directly write the factors as 3x plus y whole square. That is equal to 3x plus y multiplied by 3x plus y. Moving to question number 2, 4y square minus 4y plus 1. Here it is also a quadratic polynomial and one of the term, that is the middle term, is negative, and the first and the last term are perfect squares, that is 4y square you can write it as 2y whole square, 1 you can write it as 1 square. So think about the identity having a minus term. So that is a minus b whole square, that is a square minus 2ab plus b square. Here a is 2y and b is 1. So you can write it as 2y square minus 2 multiplied by 2y multiplied by 1 plus 1 square. That is 2y minus 1 whole square. So you can write it as 2y minus 1 multiplied by 2y minus 1. Now question number 3, that is x square minus y square upon 100. It is a polynomial of degree 2, but it is having only 2 terms and the sign is minus. So which is the identity you are having? This x square is a perfect square, you can write it as x whole square, and y square upon 100 you can write it as y upon 10 whole square. That is, you can use the identity a square minus b square. Here a is x and b is y upon 10. That is x plus y upon 10 multiplied by x minus y upon 10. Question number 4. Expand the following using suitable identities. In that, question number 3, minus 2x plus 3y plus 2z whole square. You are having the identity a plus b plus c whole square, that is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Here a is minus 2x, b is 3y and c is 2z. So you directly substitute in the identity, that is a square minus 2x square plus 3y whole square plus 2z whole square plus 2ab, that is 2 multiplied by minus 2x multiplied by 3y plus 2bc, that is 2 multiplied by 3y multiplied by 2z plus 2ca, that is 2 multiplied by 2z multiplied by minus 2x. Please be careful about the signs while writing. Minus 2x whole square, that is 4x square, 3y square, that is 9y square, plus 2z whole square, that is 4z whole square. Now 2 multiplied by minus 2, that is minus 4 multiplied by 3, that is minus 12. The variables are xy, so minus 12xy. Next term will be, all the terms are plus, so you can write plus 2 3s are 6, 6 2s are 12, 12yz. Now here one term is negative, so the term come as minus 2 2s are 4, 4 2s are 8, 8zx. So you got the answer as 4x square plus 9y square plus 4z square minus 12xy plus 12yz minus 8zx. Moving to question number 4, that is 3a minus 7b minus c whole square. Now same identity you can use here. So expand it. Instead of a you are having 3a, instead of b you are having minus 7b, and instead of c you are having minus c. That is a square. So 3a square plus minus 7b whole square plus minus c square plus 2 multiplied by 3a multiplied by minus 7b plus 2 multiplied by minus 7b multiplied by minus c plus 2 multiply by minus c multiply by 3a. 3a whole square is 9a square, minus 7b whole square is plus 49b square, minus c whole square is plus c square. Now 2 3s are 6, 6 multiply by minus 7, that is minus 42ab. Next term you are having two negative signs, so the term comes as plus. 2 sevens are 14, 14bc minus 6ac. Same way you can do the fifth. It is minus 2x plus 5y minus 3z whole square. Here a is minus 2x, b is 5y and c is minus 3z. So please substitute the value in the identity. You will have minus 2x whole square plus 5y whole square plus minus 3z whole square plus 2 multiply by minus 2x multiply by 5y plus 2 multiply by 5y minus 3z plus 2 multiply by minus 3z multiply by minus 2x, that is equal to minus 2x whole square is 4x square plus 5y square is 25y square plus minus 3z whole square, that is plus 9z square. Then only one negative sign you will have, minus 2 multiply by 2, that is 4, 4 5s are 20, 4 5s are 20, so you are having minus 20xy. Then 2 5s are 10, 10 multiply by minus 3, so minus 30yz plus, both the signs are plus, so the term is plus, 4 3s are 12zx. Question number 5, factorize. In that question number 1, 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Now it is a polynomial of degree 2 and here the first three terms are perfect square numbers. So you think about the identity a plus b plus c whole square. Now you have to find what is a, what is b and what is c. So in the first question, the first term is 4x square. It is a perfect square. You can write it as 2x whole square. 9y square, that you can write it as 3y whole square, and 16z square, that is 4z square. Now after getting the three numbers, you have to think about the signs. If any of the terms are negative, so you look into the negative terms. Here minus 24yz and minus 16xz. Look into the variable part. In the variables, which variable is coming in both the negative terms? So you can find z is the variable present in both the terms. So the term having z as variable, that term will be negative. So you, instead of 4z, you have to write minus 4z whole square. Now you just try to write the expansion of a plus b plus c whole square, that is 2x whole square plus 3y whole square plus minus 4z whole square plus 2ab, that is 2 multiply by 2x multiply by 3y plus 2 multiply by bc, that is 3y multiply by minus 4z plus 2ca, that is 2 multiply by minus 4z multiply by 2x. So after expanding this, you will get the same polynomial, that is 4x square 9y square plus 16z square plus 12xy minus 24yz minus 16xz. So you can write the identity 2x plus 3y minus 4z whole square, that is equal to 2x plus 3y minus 4z multiplied by 2x plus 3y minus 4z. Now moving to question number 2, 2x square plus y square plus 8z square minus 2 root 2 xy plus 4 root 2 yz minus 8xz. Now in this question you are having a polynomial of degree 2 and find the perfect square of the first term, that is 2x square. 2x square can be written as root 2x whole square. Root 2 square is 2. So you can replace 2x square as root 2x whole square. Y you can write it as y whole square. 8 can be written as 2 root 2 z whole square. 8 is 2 root 2. That means 2 square is 4 and root 2 square is 2. So 2 root 2 square is 8. So 8 z square. Plus now you have to look into the negative terms, that is minus 2 root 2 xy and minus 8xz. That means here the variable coming in common is x. So the term having the variable x must be negative. So you rewrite the given polynomial as minus root 2x whole square plus y square plus 2 root 2 z square plus 2ab, that is 2 multiplied by minus root 2x multiplied by y plus 2bc, that is 2 multiplied by y multiplied by 2 root 2 z plus 2ac, that is 2 multiplied by 2 root 2 z multiplied by minus root 2x. So this is the expansion of the identity minus root 2x plus y plus 2 root 2 z whole square. So by factorizing this you can write it as minus root 2x plus y plus 2 root 2 z multiplied by minus root 2x plus y plus 2 root 2 z. Question number 6. Write the following cubes in expanded form. That is, in that third question, that is 3 upon 2x plus 1 whole cube. So you are using the identity of cubes, that is a plus b whole cube. A plus b whole cube is a cube plus b cube plus 3ab multiplied by a plus b. Replace a as 3 upon 2x, b as 1. Therefore 3 upon 2x plus 1 whole cube equal to a cube, that is 3 by 2x whole cube. Please don't forget to put the bracket, plus 1 cube plus 3ab, that is 3 multiplied by 3 by 2x multiplied by 1 multiplied by a plus b, that is 3 by 2x plus 1. Now 3 by 2 whole cube is 27 upon 8 x cube plus 1 cube is 1 plus 9 upon 2x multiplied by 3 by 2x plus 1. Then you will have 27 upon 8 x cube plus 1, multiply each term in the bracket, you will get 27 upon 4 x square plus 9 upon 2 x, that is equal to 27 upon 8 x cube plus 27 upon 4 x square plus 9 upon 2 x plus 1. So the expanded form of 3 upon 2 x plus 1 whole cube is 27 upon 8 x cube plus 27 upon 4 x square plus 9 upon 2 x plus 1. Moving to question number 4, that is x minus 2 upon 3 y whole cube. Since it is negative sign and you are finding the cube, so you are using the identity a minus b whole cube. A minus b whole cube is a minus b minus 3ab multiplied by a minus b. Therefore you will have x minus 2 upon 3 y whole cube equal to x cube minus, instead of b you are having 2 upon 3 y whole cube, please put the bracket, minus 3ab, that is 3 multiplied by x multiplied by 2 upon 3 y multiplied by a minus b, that is x minus 2 upon 3 y. Now the first term is x cube minus 2 upon 3 cube is 8 upon 27 y cube minus 3 and 3 getting cancelled. So you will have minus 2xy multiplied by x minus 2 upon 3y. That is equal to x cube minus 8 upon 27 y cube minus, multiply each term in the bracket, you will have minus 2x square y minus minus plus 4xy square upon 3. Now moving to homework. In exercise 2.4, question number 5, factorize cubic polynomials. Two sums we have already done, that you have to write it in the notebook, and the marked sums that you have to write it as homework in the notebook. And from exercise 2.5, please write down the sums that we have discussed in your notebook. Along with that, the marked sums that you have to write it in the notebook as homework. Please do the homework regularly. Thank you.